Good morning friends. Today's in this video we are going to learn a new topic of adiabatic flame temperature and about flue gas analysis. This is the last topic which we are studying in unit 1 about the basic concept. So here coming to the last topic about the adiabatic and flame temperature and about the fuel gas analysis. First we are studying about adiabatic flame temperature. See, first of all, before going to know about adiabatic flame temperature, we should know what is meant by adiabatic process or isentropic process. See here in the previous classes in thermodynamics and in thermal engineering 1, we have studied about these adiabatic process or isentropic process. That in adiabatic process or an isentropic process, what is the process which we are having here means nothing but of a process in which the working substance neither receives nor gives out heat to the surrounding during its expansion or compression is called as an adiabatic process or isentropic process. That in the working substance, neither it gives heat out to the surrounding or receives heat from the surrounding during its expansion or compression. In the expansion or compression process, the heat received or heat gives out to the surrounding is nothing but of an adiabatic process. See here, this will happen when the working substance remains thermally insulated. Means when we are going to insulate to the working substance, see that no heat transfers during the process. That in adiabatic or isentropic process, when we are going to insulate the working substance, no heat is going to be transferred out or from the atmosphere, no heat or no air is going to be entered into the system. See here, we are having some points that in the adiabatic or isentropic process, no heat leaves or enters the gas. The temperature of the gas changes as the work is done at the cost of internal energy, and the change in internal energy is equal to the work done. That we should know here that no heat is going to enter or leaves the system here. The temperature of the gas also is going to be changed. The work done is at the constant of internal energy. See here, we should know that what is meant by the adiabatic here. The adiabatic means the heat receives or rejects or receives heat out from the surroundings during its expansion or compression process is nothing but of adiabatic process. By using of this adiabatic only, we are going to study in a detailed way about adiabatic flame temperature. See here, adiabatic flame temperature means nothing but in a combustion process when chemical reaction takes place adiabatically. Here we are using the name the adiabatically. Adiabatical means no heat transfers into or out of the system is nothing but of adiabatic. Means in combustion process, when some chemical reaction is going to take place here in a chamber without work done by the system and no change in kinetic energy and potential energy in a steady flow manner, the temperature thus attained will be maximum and is known as adiabatic flame temperature. Simply, in a simple manner, how we can know about adiabatic flame temperature means when we are going to insulate the system here, no heat or no air is going to be entered into the system, or the heat which has been in the system is not entered out to the atmosphere. Means when the heat is not transferring in or out of the system, then the temperature automatically will rises inside the system without doing any work or without change in potential energy or without change in kinetic energy. The work which is done in the system means the temperature, the maximum temperature which rises in the system is nothing but of adiabatic flame temperature. Once again I will explain you that what is meant by adiabatic flame temperature. Means in the system in the system, when the temperature is not transferring in or out of the insulated system, in or out of the insulated system, the maximum temperature develops in the system is nothing but of an adiabatic flame temperature. We can simply study that in a combustion process, the final temperature attained during adiabatic condition is known as adiabatic flame temperature. That when the heat is, when work is not going on, or without work done, or without any change in kinetic energy or potential energy, what is the temperature, the maximum temperature developed in the system in the combustion process is nothing but of adiabatic flame temperature, which is going to done under adiabatic condition. Adiabatic means nothing but of which cannot transfer heat from atmosphere to the system or from system to the atmosphere is nothing but of adiabatic temperature, which we can study about the adiabatic flame temperature very clearly. See here, here in the limiting case of no heat loss to the surrounding, means no heat is going to be transferred outside, means heat is equal to 0. The temperature of the products reaches a maximum, which is called the adiabatic flame or adiabatic combustion temperature. That what I have telling you here is that no heat is going to loss to the surrounding or no heat is going to be entered into the system, then the work done or heat is equal to 0. When this heat is not transferring in or out to the system, the work does not, there is no any work and there is no any change in kinetic energy or potential energy is nothing but of adiabatic flame temperature or adiabatic combustion temperature. Here we can see that H prod is equal to H reacts, since Q is equal to 0 and W means heat is equal to 0 and there is no any work here. There is no any work and there is no any heat transfer, means Q is equal to 0 and W is equal to 0. We are having an equation here like this. The determination of the adiabatic flame temperature by hand requires the use of an interactive technique that see here. Fuel air mixture. Air fuel mixture is going to be entered into the combustion chamber. This is the insulated particle. Upon the combustion chamber, it is the insulated particle. The fuel air is entered into the combustion chamber for doing combustion process here. See here, after combustioning, some products are going to be developed. What are the gases which developed here, or what is the heat generated here will not cross this insulation, means the heat which has been generated here does not process the boundary or insulation of this system, means the products here, the products T maximum. See here, the temperature of combustion chamber becomes maximum when combustion is complete and no heat is lost to the surrounding. See here, if no heat is going out to the surrounding, means the heat remains in the system itself. Means if no heat is going to be transferred to the surrounding, means automatically inside the system the temperature is going to be rises and the combustion is going to be completed fully. See here, in this definition we can clearly understand that the temperature of combustion chamber becomes maximum. Here the temperature becomes maximum. Why? Because means the heat which has been generated does not passes the boundary or does not enters into the surroundings as a system. Becomes maximum when combustion is complete. Means here the complete combustion is going to be done and no heat is lost to the surrounding, means heat Q is equal to 0. This is nothing but of the flame temperature here which we can study. Here The adiabatic flame temperature of a fuel depends upon the three stages that, see here, the stage of the reactants, the stage of the stage of the stage of the reactants, the degree of completion of the reaction, the amount of air used. Here in three ways, the adiabatic temperature of a fuel is depending upon three ways. That the stage of the reactants, how it is going to be reacted here, the degree of completion of the reaction means complete combustion has been taken or not, the amount of air which we are using here. The required amount of air should be given for complete combustion process, for completing the complete combustion process. For a specified fuel at a specified state burned with air at a specified state, the adiabatic flame temperature attains its maximum value when complete combustion occurs with the theoretical amount of air. When we are studying theoretically, see the complete combustion is going to be done here. See here, we can observe here that air fuel is entering here, and incomplete combustion has been done here. Disassociation means the products which has been taken here for combustioning has not been taken here fully, means incomplete combustion has been taken here, and the heat losses are going to be done, heat losses to the surroundings, means it is going to cross the insulation or it is going to cross the system, means T product less than T maximum, means the temperature is less than the products which has been developed in the combustion process. See here, the maximum temperature encountered in a combustion chamber is lower than the theoretical adiabatic flame temperature, means we can know the main difference that here incomplete combustion is going to take here, means when incomplete combustion is going to take in the furnace, means that the maximum temperature will not attained, and the heat is going to be lost, the heat is going to be entered into the surroundings. When heat is going to be lost, that the combustion is not going to be done very properly, or incomplete combustion is going to be happened there. This is the main difference that when the complete combustion is going to be done, when the complete combustion has been done here, means it is said to be an adiabatic flame temperature. This is what about which we can know about the adiabatic flame temperature. The next topic which we are going to deal is about Orset's apparatus, means nothing but a flue gas analysis can be determined by using of this Orset apparatus. Here in the syllabus itself, we are having flue gas analysis. Flue gas analysis is determined by using of Orset apparatus method. By using of this Orset apparatus method, we are going to calculate the flue gas analysis completely here. See, the introduction of this flue gas analysis is to have proper control on combustion process. An idea about complete combustion of fuel is made by the analysis of flue gases. By using of these flue gases, that complete combustion should be done by using of this fuel. To have a proper control on combustion process, we need to have some idea about the combustion process, how these complete combustion can be done by using of the analysis of flue gas. See here, the methane is going to be add with the oxygen to get the reaction of CO to carbon dioxide plus H2O, water. See here, the methane with oxygen reacts to carbon monoxide plus water. If complete combustion of fuel takes place, we need to observe clearly here this point, that if complete combustion of fuel takes place, then carbon dioxide is released. See here, what I am telling here is that in the combustion chamber, if complete combustion of fuel takes place, then which gas is going to be released? It means the carbon dioxide is going to be released. If incomplete combustion of fuel takes place, then carbon monoxide is going to be released. See here, we need to observe the difference here, that in the combustion chamber, if the combustion is fully happened, means the gas which is released there is nothing but of carbon dioxide. And if incomplete process or incomplete combustion has been taken place, means there the carbon monoxide gas is going to be happen. See here, thus if the gases contain considerable amount of carbon monoxide, it indicates that incomplete combustion is occurring. Means if we are having the carbon monoxide gases or carbon monoxide has been released, it means we should know that there is an incomplete combustion happening in the furnace. That is, considerable wastage of fuel is taking place there. Also indicate the short supply of oxygen for combustion, means we are not giving a required amount of oxygen for complete combustion process, for completing the combustion process. If the complete combustion has been not done, means that we need to know that carbon monoxide gas is going to be released out. If the flue gases contain a considerable amount of oxygen, it indicates the oxygen supply is in excess, though the combustion may be complete. See here, if the combustion may also be complete, there should be a considerable amount of oxygen. It indicates the oxygen supply is in excess. Means if we are going to give more amount of oxygen for doing the combustion process, also the combustion will not the combustion will be taken very quickly and has been going to be completed. See here, if the flue gases contain a considerable amount of oxygen, it indicates the oxygen supply is in excess. Means we are giving more oxygen for combustion process, though the combustion may be complete. After completing the combustion also, if we are going to give the more oxygen for combustioning process, means we are going to analyze these flue gases made with the help of RSET apparatus. See, these can be determined by using of these RSET apparatus for analyzing the fuel gases here. See here, the analysis of flue gases made with the help of RSET apparatus can be explained in detailed way here. See here, this is the diagram of RSET apparatus, which we can see in 3D. See here, we are having here the absorption pipette containing alkaline pyrogallic acid. Here in the second one, we are having here 3 frames, that the first one is observing KOH solution, is having KOH solution, and in the second one we are having the pyrogallic acid here, and in the third one we are having here ammonical cuprous chloride contains in these 3 flasks. See here, this is what the stop clocks which we are having for these 3 flasks, and here a graduated burette is having here, and we are having here a rubber tubbling, and here we are having stopcock, and here we are having water reservoir, and three-way stop clock is here, which is having here. Here we are having the filter for filtration purpose, and the flue gases coming out from the, after completing of the combustion, the flue gases which has been generated are entered. See here, the flue gases are going to be entered through these to the horizontal pipe, by using of this horizontal pipe into the into this graduated burette. See, we can study this diagram in a detailed way. Here, see, three-way stopcock is having here, filter is having here, water reservoir is having here. The stopcock for these three flasks above this, we are having stopcocks, which is used for stopping of the fuel entering into these flasks. In every flasks, we are having some solution. That in the first flask, we are having a solution of KOH, and in the second flask, we are having some solution of this pyrogallic acid solution is there here in the second one, and in the third one, we are having the solution of ammonical cuprous chloride is having in this here. And now by using of these, we are going to calculate how much carbon dioxide is observed by this first flask, and how much oxygen is going to be observed in the second one, and how much carbon monoxide gas is going to be observed into the third flask by using of this RSET apparatus method. See here, we are studying the construction of this RSET method detailedly, that consists of water jacketed measuring burette. See here, we can observe the burette here, water jacketed burette, and connected in a series to a set of three absorption bulbs. We are having the three absorption bulbs here, 1, 2, 3, and each through a stopcock. Means for these three, we are having here the stopcocks. The three bulbs are having three stopcocks here. The other end is provided with a three-way stopcock. See here, the burette, the three bulbs are connected to the burette at one end, and the other end is connected to the three-way stopcock. See, these three bulbs, the first end is connected to the burette, graduated burette here, and the last one, third one, is connected to the three-way stopcock here. So free end of which is further connected to a U-tube packed with glass hole. See here, this is, and the last one is again connected to the C, means this observation pipe containing ammonical cuprous chloride is connected to the glass tube or U-tube shaped U-tube glass here. It is connected to the U-tube glass with wool for avoiding the incoming of any smoke particles, etc. Here the graduated burette is surrounded by a water jacket to keep the temperature of the gas constant during the experiment. See here, this graduated burette is surrounded outside of these graduated burette. We are having see here, we are having water jacket. Here we are having outside, it is having the water jacket to keep the temperature of the gas constant here. The lower end of the burette is connected to a water reservoir. See here, the lower end of these is connected to the water reservoir here. It is connected to the water reservoir. The lower end of this graduate burette is connected to the water reservoir here by means of a long rubber tubing. See here, by using of this long rubber tubing, the graduate burette below is connected to the water reservoir here. The absorption bulbs are usually filled with glass tubes so that the surface area of contact between the glass and solution is increased. See, the absorption bulbs have solutions for the absorption of, see here, the absorption bulb having solutions for the absorption of CO2, O2 and CO respectively. See, Here these absorption bulbs means these three absorption bulbs are going to absorb CO2 gas, O2 and CO, carbon monoxide gases into these three. And first bulb has potassium hydroxide solution 250 grams KOH in 500 ml of boiled distilled water. Here in these first bulb we are having inside these we are having a solution of KOH, means nothing but of KOH solution is there, 250 grams of KOH is there. And then the second one we are having a solution of alkaline. In the second one we are having a alkaline pyrogallic acid of plus 200 grams of KOH in 500 ml of distilled water, and it can absorb CO2 and O2 here in the second bulb. And the third bulb contains ammonical cuprous chloride here. In the third bulb contains ammonical here, ammonical cuprous chloride here. And ammonical chloride plus 120 ml liquor ammonia plus 375 ml of water is contained, and it can absorb CO2, O2 and CO gases here. Hence, it is necessary that the flue gas is passed first through potassium hydroxide bulb where CO2 is absorbed. See here, first from here, from the burette, when we are going to release the valve, when we are going to increase the valve, the gas which has been entered directly, the flue gases coming out from the combustion chamber directly enters into the burette. And what is the gases which entered here after closing of the water reservoir valve, opening of the water reservoir valve, first the gas is entered into the KOH solution. See here, hence it is passed first through potassium hydroxide bulb where CO2 is absorbed. When the solution is entered into the hydroxide bulb, CO2 is going to be absorbed. Then through alkaline pyrogallic acid bulb, when only O2 will be absorbed. And finally through ammonical cuprous chloride bulb where only CO will be observed here. We can observe clearly the RSET apparatus here that after complete combustion process, the gases, the flue gases enters into these U-tube shaped glass fused calcium chloride, means the flue gases is directly entered into this U-shaped glass, and through this U-shaped glass, when the three-way stopcock valve has been opened, these flue gases which has been entered is directly sent through this horizontal pipe to the graduated burette here. See here, the flue after the complete combustion has been taken, the flue gases which has been released is entered into the U-tube shaped pipe glass tube, and when it is going to be entered into the graduated burette, the three-way stopcock has been opened, and the flue gases directly enters into the graduated burette. When the flue gases are directly entering into the graduated burette, the see here the bulbs, the three bulbs stopcocks are going to be closed here when the flue gases are entering directly into the graduated burette here. If these stopcocks are not opened, means the flue gases will directly entered into these three bulbs. For that, the three bulbs stopcocks are going to be closed when the flue gases are directly entered into the graduated burette. See here in the first one we are having KOH solution it absorbs CO2 gas, and the second one, it absorbs pyrogallic acid O2. In these tube, in this bulb, we are having this alkaline pyrogallic acid firstly, and in this potassium oxide KOH is having, and in the third bulb we are having ammonical cuprous. When see we here this graduated burette pipe is connected to this three-way cock, stop cock, and this three-way stop cock is connected to the U-tube, and the other end of this graduated burette is connected to the water reservoir by using of this rubber tube. When we are going to release, or when we are going to give a pressure of water, when we are going to give a pressure of water to this graduated burette, what are the gases having here? The gases increase and first enters into these ammonical cuprous, where the CO2 gas is going to be absorbed, and the weight of the ammonical cuprous solution is going to be increased here. And at the time when the solution, when the gases are going to supply from the graduate burette to the first flask, first bulb, at that time the stop cock of the first one is going to be opened, and the remaining two stop cocks are going to be closed, and the three-way stop cock valve also has been closed. The first one has been opened, and the gases entered into these ammonical cuprous, and after entering into the gas absorbs CO2, means carbon, and these carbon monoxide has been absorbed here, and the remaining gases which has not been absorbed has entered, returned back into the graduated burette. And again, when we are going to give pressure, means when we are going to release the pressure, hence the first tube stop cock is closed, and from the gases from the graduated burette directly enters into the second one, where we are having alkaline pyrogallic acid inside the second bulb. Hence, when the gas enters into the second burette, at the time the stop cock opens, and the here O2 is developed, means O2 is going to be absorbed here in this bulb, and the remaining gas is which has been not absorbed is entered back into the graduated burette. Hence, after completing of these two, again the pressure has been released from the water reservoir, and when the gas is entering into the third one, then the two stop cocks of the ammonical cuprous as well as alkaline pyrogallic acid, both the stop cocks are going to be closed, and the solution, means the gas is directly entered into the third one, means nothing but of KOH solution. There CO2 carbon dioxide gas only has been absorbed, and the remaining gas which has been not absorbed is directly entered back into the graduated burette. Here this is what how we are going to calculate or how we are going to study the RSET apparatus by observing in the first bulb, second bulb, and third bulb clearly. See here, we can study the working of this flue gas, flue gas. Flue gas is passed through fused calcium chloride, which absorbs the water vapor present due to its hydro property. Three-way stopcock is opened, and the flue gas is filled in the graduated burette. See here, we can observe that the flue gas is filled. The flue gas is passed through the fused calcium chloride. See here, the flue gas is passed through the fused calcium chloride, which absorbs the water vapor present due to its high hygroscopic properties. We are going to observe here the water vapor properties, and three-way stopcock is open. When it is passing through these horizontal pipe, the three-way stopcock is going to be open, and the flue gas is filled in the graduated period. See, the flue gas which is entering from the glass tube is directly entered into the graduated period. When the flue gas are directly entered into the graduated period, at the time the three bulbs are going, stop cocks are going to be closed. Here, see here, the whole setup is water jacketed to maintain a constant temperature. Here, for maintaining a constant temperature, the water jacket is having around the graduated burette. See here, the stopcock of the KOH reservoir is opened and the water reservoir is moved up. See here, when the water reservoir is moved up, the KOH stopcock has been opened and the flue gas has been entered into the first burette, enters into the first burette here. See here, water inflows in the graduated burette and pushes the gas to flow into the KOH reservoir. See, first it pushes in the graduated burette gas into the KOH solution, and in the reservoir carbon dioxide is observed. Here, in this reservoir carbon dioxide gas is observed here, and the whole CO2 in the sample is observed. The water reservoir is brought down so that the air again can rush to the burette. See here, what are the gas, the flue gas which cannot be observed here in the KOH is again passed into this graduate burette, and here again the stopcock of the alkaline pyrogallic acid reservoir is opened and the water reservoir is moved up. Then water inflows in the graduate burette and pushes the glass to flow into the alkaline. Secondly, it pushes the gases into the second one, and after entering into these, it has absorbed oxygen and the remaining gases entered into. This is the first one. See here, the gases first enters into the KOH solution, and second it has been entered into the alkaline pyrogallic acid, and third one it enters into the ammonical cuprous. When it has been entered into the first bulb, CO2 has been observed. When the gas is entered secondly into the pyrogallic acid, then O2 is observed, and when it enters into the third ammonical cuprous, it observes carbon monoxide gas. See here, this is what the same process is repeated with the ammonical cuprous chloride reservoir. The volume increase of all the reservoir is measured, and the amount of carbon dioxide, carbon monoxide and oxygen are determined. How we are going to determine here, the carbon dioxide, carbon monoxide and oxygen are going to be determined by using of this RSET method apparatus. See here, we are having some precautions that the reagents in the absorption bulb 1, 2 and 3 are brought to the attached mark levels one by one by operating the reservoir bottle and the valve of the each bulb. Then the respective valves are closed here. All the air in the reservoir bottle is expelled to atmosphere by lifting the reservoir bottle and opening the three-way to atmosphere. It is quite necessary to follow the order of observing gases. See here, CO2 first, O2 second and CO2 last. In the first see, in the first bulb we are going to observe the gas which is going to observe is nothing but of CO2 gas, and then second one O2 gas is observed, and at last CO carbon monoxide gas is going to be observed. This is because the observant used for O2 can observe only some oxygen, some carbon dioxide, and the percentage CO2 left would be less, while the percentage of O2 oxygen thus detected would be more. The observant used for CO2, however, does not observe oxygen or CO2. The percentage of CO in the flue gas is very small, and these should be measured quite carefully. This is what about some of the precautions which we need to take when we are using this RSET apparatus for determine the flue gas analysis here. This is what which we have studied in this video about the two topics of adiabatic flame temperature as well as flue gas analysis. Here, this is the last topic. By completing of these adiabatic flame temperature and flue gas analysis, we have completed successfully the first unit of the basic concepts. And in the next video, we are going to start a new unit, second unit about boilers. Thank you. Thank you. For clarifications or for any questions, please mail to this mail ID or please contact me. Thank you.